Okay, so this is going to be about systems of equations. We've already learned about systems of inequalities. So this is very similar, but actually I think it's a little bit easier, so hopefully you'll agree with that. So a system of equations is just two or more equations with the same variable. So I'm going to type that in here. So two or more equations with the same variable. Let me see if I can extend this box. Oh, uh-oh. Two or more equations with the same variables. So they definitely have to have the same variables. It can't be like one equation with an x and a y and another equation with an a and a b. So whatever your variables are, you want those to be the same to be able to graph those. So two or more equations with the same variables. So the system, or the solution actually, the solution to a system graphically is the point, or x comma y, where the two lines intersect. So I'm actually going to write this in here. So where the two lines intersect, so this first blank here is going to be intersect. So when you graph two lines, it's the point where they intersect is going to be the solution. Algebraically, it's the point x comma y that makes both equations true. So like a linear inequality, it's the one that makes it true. But in this case, it has to make both equations true. All right, there are three different types of solutions. So whenever you have two lines that intersect, so we're going to draw a picture of what intersecting lines would look like. Nothing special except for that they just intersect. They run into each other. So two intersecting lines might look like that. So their solution would be that one coordinate right there would be x comma y. So one solution would be the x comma y where they intersect. All right, parallel lines. So I'm going to draw an example of parallel lines. So let's say here's a line, and I have a line parallel to it. We'll pretend that those are good. Parallel lines aren't ever going to intersect. So if it's where the two lines intersect and they don't ever intersect, then there is no solution. So the symbol for no solution looks like a zero with a slash through it. And then lastly, we have the same line. So let's say we graph a line. Let's say my line looks like that. And then I graph another line, and it happens to be the exact same line. So again, let's pretend that that is perfect and this exact same line. Then it is infinite solution. So I usually write out infinite, but you could draw the symbol for infinite, which is the little sideways 8. So solving systems by graphing, the first thing you want to do is to make sure the coordinate or the equations are in y equals mx plus b. So step one is to make sure equations are in y equals mx plus b. So I'm going to write that in here. So step one, put equations in y equals mx plus b. So they have to be in slope-intercept form to graph. So put them in y equals mx plus b to graph. Okay. The next step would be to graph the two lines. So step two is going to be graph the two lines. So graph the two equations or lines. Step three would be to identify the intersection. So identify the intersection. And the intersection, unless it's parallel or the same line, should be some x comma y coordinate. All right, so let's look at some examples. So we're only going to start with number one. So it says solve each system of equations by graphing. So again, step one is to put the equations into y equals mx plus b to graph. Well, these are already in y equals mx plus b, so we can skip that. Step two, graph the two equations. So that's where we're going to start. So we're going to start by graphing y equals x minus 8. So when I'm graphing y equals x minus 8, I start at the b, the y-intercept, which is negative 8. Then I rise and run using the slope. So the slope here is that imaginary 1 in front of the x. So that's going to be 1 over 1. So we start at negative 8, then we rise 1, run 1. I'm going to do that. So start at negative 8. So these graphs go, they're 10 by 10, so that might help by a little bit for graphing. So this is going to be 0, negative 8. Then from here, we're going to rise 1, run 1, rise 1, run 1, rise 1, run 1. So to make that a little bit faster, just know you could rise like 1, 2, 3, 4 and run 1, 2, 3, 4 because 4 over 4, 4 divided by 4 would also be 1. So you don't have to just plot every single point. It helps to draw a straight line, but you don't need all of them. So if you are feeling a little bit lazy, just know that it's a way you could make it a little bit quicker. So I'm going to just plot each one of these. And then I'm going to draw that line. When they're equations, you don't have to worry about dashed or dotted. It's just always going to be just a solid line. All right, so that's going to be pretty good. So there's that equation. So I'm going to label this point over here as 8, 0 as well. So I'm still going to keep with labeling 2 points. All right, the other one, y equals negative 2x plus 1. So we start at our y-intercept of 0, 1. We rise and run negative 2. So we're going to start at 0, 1. From there to rise and run negative 2. That's negative 2 over 1. We're going to go down 2, right 1, down 2, right 1. So it is important that you get points because you're going to need to find the intersection. And if you don't have points, it's hard to know where that is. So down 2 and right 1 or up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. We're going to draw our line. All right. So you probably have already figured out that they intersect at this point right here. That is what we're looking for. So step 3 is to find the point of intersection. So this point right here is the solution. So that point is 1, 2, 3, negative 1, 2, 3, 4, 5. So 3, negative 5 would be the answer to this system of equations. So the coordinate 3, negative 5. So that would be the answer to this system. All right, I'm going to show you we'll go to number 3. So number 3 is different because these are not in y equals mx plus b. So the first step, step 1, which we skipped on number 1, is to get them to y equals mx plus b. So we definitely need to be able to do that first. So number 3, we have negative 3x plus y equals 8. So to get this to y equals mx plus b, this time we're actually going to add 3x. We don't do that very often. We normally have to subtract, but in this case it's already negative. So we do that, we get y equals, we cannot add 3x's to 8 because they're not like terms, so we just bring down both of those. So 3x plus 8. All right, and then we're going to do, I would go ahead and do the other one. So it is negative x plus y equals negative 2. So same thing, I would add x. So we get y equals x minus 2. We don't have a coefficient in front of either of these y's, so we didn't have to divide, but normally our last step would be here to divide. In this case, we didn't need to because we don't have a coefficient, so we can just graph. So we're going to start, I'll graph the first one. So I'm going to start at the y-intercept of 8, then use my slope, which is 3 over an imaginary 1, to rise 3, run 1. So we're going to start at 8. So on the y-axis, 0, 1, 2, 3, 4, 5, 6, 7, 8 would be right here. So 0, 8. And then we would rise 3, run 1. So I can't rise 3 because it actually runs out. It would be up here in this space right here. So instead, I'm going to go down 3 and left 1. That's negative over negative, which would make still a positive line. So we're going to go down 3, left 1. Down 3, left 1. Down 1, 2, 3, left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. 1, 2, 3. Let me move my graph. Left 1. Okay, so I'm going to draw that line. All right, the other one, let me zoom out over here. The other one, my y-intercept is -2, and my slope is that imaginary 1 in front of the x, so that's 1 over 1. So I'm going to start at -2, then I'm going to rise 1, run 1. So -2 is where we're going to start. So at 0, -2. 0, -2. And then from there, we're going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, over and over again. Can also go down 1, left 1, down 1, left 1, down 1, left 1. So once you have those, you can graph that. So we are looking for the point of intersection, which you probably, again, have already found. It's going to be this point right here, where they intersect. So that is the coordinate at -1, 2, 3, 4, 5, -1, 2, 3, 4, 5, 6, 7, -5, -7. All right, so there is the answer to that. So our solution for that one, it would be, and I'm going to put it in this box down here, -5, -7. All right, since we've already done that one, I'm also going to show you how you can use your calculator to check that. So a couple of things that you definitely need to know how to do using your calculator. So, did not mean to close that all out. Let me see if I can get that back up. Let me get my iPad screen back up here. Okay, so I don't know how to, here we go. Okay, so using my calculator, I can check this. So you could graph these as relations, and it would just basically graph it for you. You could graph your y equals lines that you got, confirm that they're the same, and then you can actually use your calculator to find the intersection. So I'm going to show you how to do all of that real quick. So I would add a graph. So let's pretend I'm starting from scratch. I didn't do all of this right here. I'm just starting with -3x plus y equals 8 and -x plus y equals -2. I can graph those as a relation. So I'm going to delete the equal sign, choose number 6, and I'm typing in on my paper, or what's on my paper, -3x plus y equals 8. So there's that one. I'm going to push tab. I'm going to type in the second one, which is -x plus y equals -2. So there they are. If you want to drag to see the intersection, where you just click and drag and hold. So I would agree that these look very similar. If you wanted to just confirm that your math right here was correct, because you should definitely be able to do this, you could graph both of those lines also. What you should see happen is this purple line, y equals 3x plus 8, should line up perfectly with this blue line, because the blue line was the first one we did. The green line, y equals x minus 2, should line up with the red line on my calculator. So I'll show you that real quick. I would type in, you could change it back to a function because they're in y equals. So to remember to change it back to a function, we can change it to graph entry edit, number 1 function. So my first one was y equals 3x plus 8. So this is the first one. It should line up with the blue line. There it is. The first blue line lines up with the blue line because that's a function and a relation. Push tab. The second one was y equals x minus 2. So hopefully this one lines up with the red line. There it is. So I have confirmed not only that what this right here matches what I got on my paper, but my math matches what this gave me up here. So I got all the same thing. All right, so the next part is probably the coolest. To find this point of intersection, we can do trace, menu 5-1, and you can just trace toward it, okay, but it's not always going to land right on it. In this case, it's not landing on it because it's not telling me that. So that doesn't help me any. So I'm going to push menu, number 6, analyze graph. And we want to find this intersection right here, number 4, intersection. So it's asking us on the graph, you can just click on the graph. I accidentally clicked something else, I have to do it again. So menu, analyze graph, intersection. So I'm going to click or not. Let me see, what is this doing? So -5, -7, I traced to it, so there it is. I'm trying to see how I can get it to tell me the intersection. Click 2 function or equation graphs and then click search bounds. So we're going to click this one and this one. There we go. So I think because I graphed those 2 extras, it wasn't working. Normally, it would just automatically pop up with this dash line. So it's asking me to highlight this. So I'm going to click. It says lower bound, so usually that's on the left. Then I'm going to drag it so that it highlights, and you should see when I go over it, it pops up a yellow box that says intersection. So I'm going to click again. And there is that intersection. I had already traced to it, but there it is, -5, -7. So I'm going to show you with the calculator on a different example because I think I messed that up by putting some extra stuff in there. So I'm going to do I'll do number 4 just by calculator. So number 4, I'm going to push, in my calculator, I'm going to do a new document, add a graph. So the first one is x plus 2y equals 4. So I'm going to delete the equal sign, choose number 6, relation. So x plus 2y equals 4. There it is. I'm going to push tab. This one is y equals -1/2 x plus 2. So you could just type that all in. Because that's a function, you can also do graph entry edit number 1 function. So -1/2 x plus 2. So -1/2 x plus 2. So this one's funny. I didn't realize that this was a funny one, but what happened is we graphed a line and then we graphed another line on top of it. So this is one of the special case ones. So when we have 2 lines that are the exact same, then it is infinite solution. So this would be an example of an infinite solution. If you try and do intersection on this one, it is not going to work. We would do this and then this, and it's telling you some random intersection, but if I do it again, analyze intersection, I say here and here, it's going to tell me a different intersection. So every time it's going to tell me a different one because it's just picking the closest to where I clicked. So the most important thing is that you realize you graphed a line and then you graphed another line right on top of it. So those are infinite solutions because they intersect at every single point. All right, let me see if I can find one that's not like that. We'll do number 5. So number 5, let me try it again. All of this because I messed up on the first one. So add a graph. So I'm going to graph x plus 3y equals -15. So to do that, I'm going to delete the equal sign. So x plus 3y equals -15. There it is. I'm going to push tab. I'm going to graph y equals -7, so I'll just type it this time. Y equals -7. Okay, I can't actually see that, so I'm going to click and drag. -7 is too low for me to see it, so I'm just going to drag it up. So there is the point I'm looking for, where they intersect. So to find that, menu, 6, analyze graph, number 4, intersection. So see how it automatically popped up. So it's asking me to, right here, it says lower bound, question mark. So I'm going to click on the left side. It really doesn't matter. But I always make sure and do the left side, and then it says upper bound. See right there, it says upper bound. So I'm going to click, I'm going to drag until I highlighted it, and it should pop up and tell you. So there's our intersection 6, -7. So that is the answer for number 5, 6, -7. So we'll graph that on our paper, but let's go ahead and get that answer down. So the number 5 is 6, -7, and then we'll graph it on our paper in class.